Welcome to Embedded. I am Alicia White, alongside Christopher White. Our guest this week is Dr. Sonia Grego, and we're going to talk about smart devices, health monitoring devices, developing systems for faraway testing, careers, and probably the words coprolite or scatological.
Hello, Sonia. Welcome to the show.
Hello.
Could you tell us about yourself as if we met at, I don't know, a Duke University industry event?
My name is Sonia Grego. I am a scientist and an innovator. I work on technologies that improve health by dealing with human waste, also known as smart toilets.
In fact, your lab is the Smart Toilet Lab. Is that right?
That is correct.
So many questions. So many questions. But before we ask them, we want to ask you short questions. We want short answers, as this is lightning round. Are you ready?
I am as ready as I can be.
Which country have you tested in that was the most difficult?
India.
Favorite or least favorite poop joke?
My favorite poop joke is that my career went down the toilet.
That's great.
What is your favorite plumbing tool?
My favorite plumbing is not as much a tool as a component, is the S-trap or P-trap of a toilet.
Keeps all the bad things from going the wrong direction.
It's amazing. It's an amazing invention that was made before plastic. It's a shape of a pipe, and that's what makes indoor plumbing possible. That's what makes your home having a bathroom by your bedroom. That's a shape of a pipe. That's what the S-trap does. It's amazing.
What's the easiest fix for better sanitation around the world?
There is none.
Okay.
There is none that is easy. There is none that is easy. It's really a big challenge. That's a lot. I've worked at it with many other people in large programs for over a decade now. And yes, I see. I understand why it's so difficult. It's not impossible. It has to be done, has to be addressed. But there is no easy fix.
What is your favorite sensor?
Oh, my favorite sensor? Well, I love cameras.
Complete one project or start a dozen?
Start a dozen.
Do you have a favorite fictional robot?
Oh, you guys, I am more fond of robots that are practical, that do something for me than characters robots.
Favorite real robot?
Favorite real robot? Well, I'm thinking something like a Roomba is helpful, but of course my favorite robot of them all is the smart toilet we have developed for health monitoring. We call it Athena internally, so I would say Athena, but nobody knows Athena, but that's certainly my favorite.
If you'd said Athena, I would have thought of a robotic owl. I don't know what that's from.
Clash of the Titans.
Oh, gosh. Do you have a tip everyone should know?
Most certainly. Eat more fiber.
All right.
Unless you're me, and then don't.
is the ingredient for long life. I've discovered recently through my work that helps with your health, and I've seen the benefit myself. So yes, add a scoop of beans to your salad.
So Coprata, you are the CEO of Coprata, which is a spinout of Duke University?
Correct.
And what does Coprata do?
It Coprata, we are transforming the way gut health is measured for consumers and for researchers. We have developed a smart toilet that monitors your health and collects data in real time, and also rapid at-home tests that tell you about your gut health and how the microbes in your gut are doing.
And the at-home test is I'm not sure how we're going to get through this delicately.
It's a send-away thing, like the...
No, it's not the poop in a bucket.
Wow. It's not a bucket, but okay, go ahead.
It's a more like a pool pH test.
Okay. A litmus.
A litmus, and you check the colors your phone. You take a picture so that the colors are matched after the chemistry happens. Actually, I guess I should have let Sonia explain it.
Yeah.
No, but you explained it very well. So most poop tests require a laboratory, and you ship in the specimen to a laboratory, and those are complex, sophisticated analysis. We have developed a method by which a well-established indicator, fecal pH, is measured at home through a strip and through our specialized collection system. The challenge, but also the opportunity for gut health, which is so important for your overall health, is that the information is in poop. So yes, I talk and work with poop a lot. That's my thing. I think the stigma that the world has for poop is misplaced.
And there's a lot of research to show that our gut biome is super important, poorly understood, affects our serotonin, so our brains and happy chemicals, affects our immune system. But that's all biology. It's cool biology. It's exciting biology. But where's the engineering here?
The engineering is in the fact that poop is where the information is, and poop is an extremely difficult material to work with. It's
brown and sticky.
No,
yes,
a stick.
Wow.
Sorry.
Oh no, you go for it.
No.
Go for it. No.
No, I'm holding your back now.
I was going to save that one for the end, but I just couldn't, because as you say, there's not only are there all of the social stigmatisms, the disgust reactions, the horror, the actual, it is a biological waste, so you don't want to play with it.
Mm-hmm.
There's also mechanical properties to it that make it difficult to have a system. I mean, I worked on a water filtration system recently. It was all robotic, and we had to move things here and there and then flush out our lines. And it was very cool, very robotic. And I can't imagine having to do that with something that has such a different viscosity, turbidity.
Exactly. Thank you for recognizing that. Absolutely. So of human excreta that contain health information, there are urine and feces. Both are excreta. Urine is comparatively much simpler to use because it's a fluid, and we know how to move around fluids very well. That is established.
Not necessarily easy, but established.
Well, not easy, but it's established. Has been done before. Stool is very different. It's a solid, although it consists of 80% water. It is much more water. Even your, hardest looking things is still 80% water, which is amazing. Its physical form is so different. So we need to be able to handle anything that goes from very hard to practically liquid. And actually, the consistency itself is health information. And it's super sticky. So typically it's handled for health analysis with single-use components, which is clearly not trivial in our case. So yes, and it's a solid and it's dropped in liquid. So you need to learn, and that's really what my team has, an expert of separating engineering devices, and they are electronically controlled systems that separate solid from liquid and extract a small amount of specimen in a predictable way, flush away the rest. For analysis, you really need a small amount, but yet no cross-contamination. And doing all of this away from the purview of the user. As you said, it's disgusting. Nobody wants to see it. Nobody wants to handle it. So in our smart toilet, everything happens in a place which is invisible to the user after the toilet has been flushed. Super difficult engineering.
But you've also worked in sanitation, not just smart toilets, but other forms of... Let me go back. I never really considered much about wastewater treatment plants until COVID, when suddenly there was a way to see if my community was currently experiencing a surge.
Yeah.
But that actually, there are a lot of different tests that can happen for different areas of the world. My particular wastewater treatment, I don't believe, looks for helminths. Is that what that word was?
Yes, parasites. Yes.
But it would be better to track that in area with heavy parasite problems. Do you work on that sort of sanitation wastewater problem as well?
Well, yes. And the bigger issue with sanitation and the wastewater treatment plants is for places that don't have one. And I am sad to say that roughly half of the world population is calculated at 4 billion people, which is or approximately, do not have safely managed sanitation. So when these are countries where the waste is flushed down the toilet, but then there isn't a sewer system that brings it to a appropriately sized wastewater treatment plant, and waste is just seeps, is drained in the ground near where people live, contaminates the water, causes needlessly cases of diarrhea. Children, roughly 5 million children, die worldwide every year because of poor sanitation. There are very preventable diseases that cause hospitalizations and also an economic impact in lost work. So the biggest problem for the world is where the wastewater treatment plant is not there. Happens sometimes in the US also, when Helene happens, for example, in North Carolina, the wastewater treatment plant went and people did not have, neither sanitation nor water.
The hurricane, Helene.
Yeah, the Hurricane Helene, yes. So the challenge globally for the lack of sanitation is that it's not economical to build a sewer system network in super crowded urban places like the city of Mumbai in India. It's over 20 million people all living on top of each other. There is no building a sewer system that brings waste away. So the grand challenge in sanitation is developing systems that treat the waste on site where it is produced, essentially at the toilet or household level, creating a resilient network of treatment as opposed to a centralized system. And that is also a super hard engineering problem.
There are parallels to the electrical grid system, that the centralization versus decentralization problem.
Absolutely. Absolutely.
You recently wrote a book, Engineering Field Testing of Non-Sewered Sanitation Systems, a compendium of lessons learned. And when I told you that I planned to look through it, I really was planning to look through it, and then I got distracted and didn't. And then when I finally opened it, I was like, this is basically a list of what everyone needs to know about, what everyone in the U.S. who has comfy, cushy desks needs to know about developing products for places that are dry and dusty and difficult to work with, difficult to work in. We get comfortable making solutions that we are not part of. And that's a terrible, terrible idea. Could you describe a little bit more about that book?
Yes. I had the opportunity and the privilege of leading a large international program for the Gates Foundation. Multiple teams in the US and Europe mostly have developed prototype technologies to treat waste at the point of production at very small scale. And these are, by the way, amazing technology. These are physical, chemical, mini factories, the size of a refrigerator, more or less, sometimes bigger, that treat the waste without needing a sewer. This is very difficult to do. You cannot put a sewer in a wastewater treatment plant in a box, because wastewater treatment plants rely on bacteria to digest the waste. So they need space and time. And the biology does not scale well at the household scale, much smaller. So they cannot be miniaturized. So new principles need to be developed. And they have been developed, a lot of amazing technologies. For example, electrooxidation, using the salt naturally present in urine, in the wastewater, and the discharges from toilet can be used to with electrodes to generate to use electrochlorination to disinfect that waste itself and have no bacteria discharge. This has been demonstrated in the US multiple times. And my role in field testing was design the protocols for the deployment of the system as they were field testing in an actual setting where they were to be deployed. And India, I've worked both in South Africa and India, and in India extensively. And yes, the systems failed. We were field testing, so we were operating the system to failure points to record what that was, and that was they failed fast. There were a lot of factors that were not considered, despite all the planning of the engineers, and that was a lot to do to the fact that this is new, and also a lot to do with the environment. And the book summarizes all the lessons learned from this test to failure.
What I was most fascinated by was not the specifics dealing with the toilet itself, but the fact that of the 22 pages of the short lessons learned chapter, at least 8 of them were things that I definitely have seen myself. The standards and the local municipalities all have different rules, and that's just in the U.S. How do you put this into place? One of the things that really caught my attention was, how do you remove it? Because once a community actually likes your device, you can't take it away and ask them to go back to a subpar system, or the whole how do you remove it usually isn't part of the discussion for when you're preparing the site or selecting the site. And this went through it went through so much of what I have seen, and it was in such a different perspective because it was about toilets, but it also was about finding the right stakeholders and getting them engaged, and user manuals or the developers don't want to tell the end users how everything works. The end users need to know in order to fix things.
Yes. Communication turns out that the one of the biggest element of field testing, the technologies, and where many disappointment take place is communication and the challenges thereof. Absolutely.
Were there any particular lessons you found surprising?
Oh, yes. We hired local people to be liaisons with the community where we wanted to install the system. And it was super important that these liaisons were experienced, not to young people, authoritative figures that would engender trust, that they were associated with the local university so that people would trust, like to have these new weird gizmos installed in their community. But then the habits in the bathroom, whatever happens when people close the door and do their business, I did not know there were that many variations on the use of the system. And yet, because we had sensors downstreams to check exactly what was going on for the benefit of the technology, we turned out to learn a lot about people behavior. We end up writing a whole paper. We end up doing a survey, then asking the women user how they were squatting on these toilets, and realized that, yes, the orientation, for example, is not a given. So, yes, learned things that no engineer at the design stage, months, years before would have known or thought of.
It's a very taboo thing to talk about, and it's not like you can put a camera in there and nobody's going to let that happen.
Nobody's going to let that happen. Absolutely. And even having simple sensors like a door switch, people were very suspicious. So yes, that's one thing we learned and then have used for all our technologies development since. Going to the bathroom is such a private act, is such a delicate part of the routine that people don't like, and much novelty in that. They really want things to look like what they're used to. And then the taboo of the topic, that is actually something that is really common to all cultures. Yet it's so important for both sanitation as well as health. So yeah, that is certainly a challenge.
Coprata, in its current form with the MAT, what is the name for those?
Yeah, MAT kit, Microbiome Activity Tracker. It's our test.
Is relatively not electronic, or the ones you were putting in the field more electronically controlled or sensified?
Well, at Coprata, our kit has no electronic component except that the data is uploaded. We use the user phone to upload the image to our digital ecosystem for color analysis, so that the result is uniform and confirmed by by an automated system. The Coprata Smart Toilet, which is a toilet that does not treat waste, that analyzes waste for health information, that is certainly electronically driven. We had PC board sensors, moving components, and yes, the whole and electronic controls software. So it has been operated in people's homes, and the data was uploaded to the mothership.
Okay. It's like, nope, not the data. You can't have it. It's really funny how many buttons it pushes. How do you deal with that aspect of, many people are becoming more sensitive about their data being uploaded to a cloud server. But this data in particular, even though, I've uploaded a lot of health data, but apparently this triggers that same bathroom area privacy issues that are beyond the privacy issues I associate with computers. How do you convince users that this is good?
That this is good. Oh, the users that are interested in these technologies, they want the data. We are not taking data away from people. People do not have knowledge about their body. This data provides information intelligence on what is going on in their bodies. And so individuals that have digestive issues, for example, they are really eager to know, is this fine? Is this not fine? Or are my patterns changing based on my lifestyle? We had a pilot study with healthy users that were just curious about their bowel habits, and one of them had a really hyperactive digestive system, but then we observed that it improved. It came closer to average, everybody's values, and we learned that that person had changed job and had started to work more to travel less for work and eating better at home. And he said, and the toilet was able to measure that. But then that reinforces better habits, that, if you eat better, then your digestive habits are better.
You mentioned fiber, which is super important. And we've also mentioned parasites, which are also super, super important. And they both come out of the same sensing, I want to say methodology, but not exactly sensing, the same output of the...
Yes, analysis, yes, from the same analysis.
Thank you. But they are so different. And fiber is probably more lucrative, but I would argue that parasites are way more important. How do you figure out what you're going to do today?
Mm-hmm. Well, it depends on the settings. So parasites, the Helminth tests are not common in the US. They are common in India.
Right.
And that analysis is important to inform public health officials, because they can do, especially for children in schools, they can do round of medications to eradicate the problem. So it's important to know if you have a problem at the community, because then you can distribute medication and fix it. The fiber is important in the US because it turns out that, especially after you hit age 40, and I'm about to reveal that I am over the age of 40. So after that, when you've always been healthy and eaten your veggies, you go to the doctor for your annuals, and they tell you that your cholesterol is getting worse, and that, oh, your glycemic, the sugar in your blood is getting high. And to me, for example, the word pre-diabetes was mentioned, that I'm like, oh, diabetes, that's for old people, not me. and all of that depends on there are genetic effect, but a lot of it can be modified with lifestyle and fiber, for example, replacing less healthy food with fiber. And going to the doctor once a year is not enough of a motivation for me, or for, I think, other people to eat better. But if you have a test that you can do at home on a regular basis every few weeks to see if your regimen is okay, or if you're improving, then with a feedback loop, you can improve your lifestyle and your chronic diseases, which are the problem you were saying. How about the parasites? Well, in the Western world, the chronic diseases like high blood pressure, cardiovascular disease, and diabetes are the major health problems. And better diet and more fiber is a major, major factor to improve it. But there is no feedback loop. People can use a wearable and count their steps, and there isn't much to lie about it. If you're active or not, a sensor tells you, and in many people, it is motivating. We're doing the same thing with your diet, and get the information from where it can be found.
And there's celiac disease and irritable bowel syndrome and all kinds of things that makes people's lives much more difficult, that is often hard to pin to the cause of that difficulty. Can you help with that? Or is it a matter of, yes, your stomach hurts this week. We can't tell you why either.
Mm-hmm. The test that there are tests, and there are there is a lot of suffering. I learned through my collaborations with many gastroenterologists. We work at Coprata with gastroenterologists from many universities, Duke and Mount Sinai and Michigan. And the gastrointestinal diseases and issues are extremely common. And then because of the stigma we spoke about before, people may not think about it, but their quality of life super impacted, like the ability of, not living within a few miles radius from your home, the ability to travel, to enjoy life, to go places is impacted. So gastrointestinal diseases are common, and they may not kill you, but they certainly have dramatic impact on your quality of life. So need to be managed. We at Coprata, we do not diagnose diseases. For that, laboratory tests are needed. Our test is for healthy people that are interested, like me, to stay healthy really, really long time. And for those who past the age of 40 start to get a signal from their body that something is going off, having information that tells you whether the gut microbiome, the gut microbiota, the microbes in your gut, whether they're thriving or just getting by, that is information that, in my case personally, and with our technology, we think people will be motivated to improve their lifestyle and then observe a difference in the absence of symptom. That is the power of a rapid test for health people. We make visible data that is otherwise not captured, and so that people can change people can make informed choices and live healthier longer.
So you have the little kits that are color-based and use a phone to tell you what the answer is, but themselves, there isn't much electronics there. But you're not selling the smart toilets yet. What are the barriers to productization?
So our smart toilet, which is focused on gathering health information, can collect two type of information. It can collect, I would say, physical data from your waste, that from appearance and bowel habits. And we have deployed this toilet and demonstrated that we can do that. But the most valuable information is this biochemical test of your poop that allows to tell whether your microbiome is thriving or not. And before we integrate this biochemical ability in the toilet, which will require quite some level of effort and engineering and troubleshooting, we want to validate the market and determine how people use this information. So we're selling the test as a market exploration opportunity, and also the ability of providing this capability right away if people are interested. Our long-term plan is to have this biochemical analysis capability seamlessly integrated with our toilet. That is a home appliance people will buy and use routinely and have all this information available to them.
So the smart toilet now is primarily optical based. It has a camera, and not a camera where you're thinking, quit that, that's disgusting. But beyond where the human interface is.
Yes.
And the camera can tell things. I don't really want to be too graphic, because I did learn that there's a scale.
Yes.
What is that scale called?
It's called Bristol Stool Scale. It was invented by two physicians at the University of Bristol in the UK. It is a scale 1 to 7 used worldwide to describe the shape of your waist.
After reading about it, I started looking at my dog's poop and started scaling. So Christopher's going to have a good walk later.
No.
And isn't that funny how people can deal with their pet's waste, no problem, but your own, that reflects your own health, it's hard to watch. Yeah.
So the optical scanner, camera, let's be clear about that, can be fully separated from the waste and can remain in a clean box, waterproof, but has a window. So I think we can all picture the Lexan box that would require, with some electronics, and then maybe BLE, Wi-Fi. How do you?
Yes.
Okay.
We used Wi-Fi to upload the Wi-Fi of each of the houses where we deployed our system.
And then you need it's the chemical sensing, because it has to touch something.
Yes.
And then it has to be washed.
Yes.
The robotics associated with that are relatively complex. How far are you from, I mean, there's the biochemical sensor, which, as we said, color, actually not that hard once you have everything put down.
Once you have an itty-bitty specimen, as you said, yeah, not easy, but doable.
But in the toilet, you're talking about having to isolate a sample and then process it by adding water, I suppose. But you may end up adding other chemicals later to find other things. And then you need to flush. Not making a joke. You have to
clean. Reset.
Reset the system.
Yes.
how much of that is viable at this time and how much of it is we need to figure out the chemistry is interesting to people?
We have figured out how to take a small, roughly 2%, 1 to 2% fraction of a stool and make it available to analysis automatically, no hands touching anything. So we have demonstrated the ability to isolate a small portion of the specimen for biochemical analysis, take it out of the plumbing, all away from the purview of the user, and fully automatically with a system that uses water, motors, valves, electronics, and I guess cleverness of my team.
And so you end up with vials, samples that then can be
well, what we have demonstrated that we can get vial of samples to demonstrate the principle,
mm-hmm.
but the ultimate use of the technology is using that specimen not in a vial,
right.
is applying it directly to a sensor so that for the biochemical analysis. So we have all the pieces of the puzzle for a toilet that does biochemical analysis on site. And yeah, so we are the barrier is not technology now, is market, is convincing ourselves and our investors that this is the parameter and this is the market. There are many, we have assessed many analytical parameters in the specimen that could be tracked, and some apply to people with diseases, some apply to healthy people. And so there the choice is really the market. Is market driven, is not technology driven.
I could see that. Although having worked on a water robotic system that is supposed to live in the wild for long periods, building 1,000 of these is going to be very hard. And getting them all to do the robotics and moving samples around. Have you looked at that as an engineering problem, or is it primarily still science and information gathering?
Oh no, I think our design is highly scalable. It's not. We don't envision a challenge. We have demonstrated multiple prototypes. We have deployed them in a bathroom for several months to prove the self-cleaning ability of the system.
Have you ever had to firmware update your toilets?
Actually, yes.
It's remote, right?
Yes, it's all remote. And that's part that part, of course, will be a continuous source of improvement and changes. So in the course of our testing, yes, we did remote firmware. We also changed the timing, tweaked parameters based on the users. It is a bit weird to think. So one of our Athena toilets was in my home. So yes, I could tell remotely when it was used or not. And yeah, I thought that for a moment, that was the place on the earth with the most advanced toilet ever.
Multiple users is something you're going to need to deal with a shared toilet, which honestly, most of them are.
Interestingly, here in the US, we are privileged, and most toilets are used, for example, in the primary bedroom of a household by 2 people, no more than 2. We had a system that was used by 6 people in a shared environment, but we found in our pilot that it was mostly 2 people, and we had a him and a her button for the analysis. So this part was actually simpler to address. Then other things, let me tell you, toilet paper. There is toilet paper in there together with your specimen. That was much more of a challenge. We solved it, but
we have sampled your sample, and you are a tree.
No, we could tell something. Did not go right. So back to the drawing board. So we had those challenges in the many iterations we worked on super fast. That's the advantage of being a startup company over a university laboratory. Like the speed of iteration was significant and exciting.
How long has Coprata been around?
So we were incorporated in 2021. So we are, 5 years now. And what a ride it has been.
How is it different being a research professor with a lab versus the CEO of a startup?
Well, some things are similar, some things are very different. So what's similar is that to start anything, to do anything, you need funding. So money is the common thread. Also, in both cases, you have to manage technical risk. So decide how to allocate your resources toward activities that they are the most likely to produce a result. The goals are also different. For a professor, the goals is a piece of knowledge that can be disseminated in a paper, while the goal for a company is a product that people use. Where academic and startup are very different is the fact that the activity, the product in the company is so driven by the market. So what the users and buyers would want is front and center and needs to continuously be investigated and iterated upon. Of course, you're inventing something new, so you cannot ask people, do you want this? Because they'll say, I don't know what it is. So it's a very challenging task for a professor, but I have learned the hard way, I think, to go about that.
What do you wish you could have told yourself before you started the company?
I would have said to myself, don't trust the fact that a handful of physicians are excited about your product. They are neither the user nor the payer for this product. So truly go find people that would be the users and those who would pay for it and ask what they want. Eventually, I got there, and now I am more strict about it. By the way, often in entrepreneurship class, or in accelerators, they force founders to have 50 interviews. And I now, at first I thought, well, that's really excessive. Now I think it's an enlightened strategy.
Yes. If you're thinking about doing a startup, find 50 users. If you can't find 50 users, you can't find 50 people who will pay for it.
That is the message, is not as easy as you would think.
No, it really isn't. Let's see. I have a couple listener questions. Let me see if I can boil Kevin's down. Some of what we do with gut health is through a laboratory, or through like a colonoscopy, medical tests. Is what you're doing on the path to those? Can I if you say, I want to instrument your toilet, I have to admit, I would not be excited to pay more for that because just I don't need more data in my life right now. But if you said you can have a colonoscopy much less often, then I might actually be into that. Are you looking at trying to get consumer adoption by removing other disliked activities?
Yes. So what you're describing is a medical application of our technology. And absolutely, the technology of a smart toilet would benefit, individuals that are already diagnosed with a chronic disease, for example, Crohn's and ulcerative colitis. These are lifelong diagnoses that people get in their 20s, and they essentially need a lifetime of medication or medical care and to manage their condition. So we really learned a lot from this community, and we think this technology, once it's established, it's in production, there are many barriers for a technology to become a medical solution, but that's a community that would certainly benefit from this type of technology. Also, screening for colorectal cancers at the population level, that's something we have looked at. So if there was such a toilet in every gym, in every doctor's office, in every health facility, one would catch people that are not as diligent as you and know that they have to have their colonoscopy at regular intervals.
Yeah, one in the doctor's office. I mean, it would be odd, but...
And it would be difficult to time. But the question is, if our dream is if every toilet was a smart toilet, then whatever you're using, no disease that is easily detectable, but in a place where most people don't want to look at, which is your waste, would be caught. And colorectal cancer, for example, is on the rise. All the other cancers are going down in frequency. The colorectal cancer is the one that is instead going in the wrong direction, is increasing and being detected in younger and younger people. So I feel like that. I feel strongly that more analysis of your poop will help keeping more people healthy or catch problem early when they can be better dealt with.
Sonia, I think that's a good place for us to leave it. Do you have any thoughts you'd like to leave us with?
Not particularly.
Our guest has been Dr. Sonia Grego, founder and CEO of Coprata and professor at the School of Engineering at Duke University.
Thanks, Sonia.
Thanks so much for having me. It was fun.
Thank you to Christopher for producing and co-hosting. Thank you to our Patreon listener Slack group, especially Kevin and Pedro, for their questions, for their real questions and not all of the others. And of course, thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded FM. And now, wow, I have a whole list of poop jokes to leave you with. I don't even know where to start. I mean, the brown and sticky one was where I started, of course, because that's the best joke ever. Christopher, are you just going to cut me off here, or are you going to let me tell these?
We can decide after.
All right. We'll see how long he lets me go for this. Are you ready for a poop joke?
Sure.
Nope, they stink.
That's enough.
You mean poop jokes aren't your favorite? Are they at least your number 2? Did you hear about the constipated accountant? He just couldn't budget. Really thought you'd stop me by now.
I'm going to stop recording.